Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about the solid mechanics and material subject. So in this subject, already we have discussed various topics like simple stresses and shear force and bending moment diagrams and the slope and deflection of various beams, the theory of simple pure bending. Torsion also we have discussed, and springs and theory part is covered. Now in this session, so I want to explain about problem solving, the problem solving on torsion. So how to calculate the torsion for a particular given shaft. It may be solid or hollow. And one is calculation torsion shear stresses and the diameter of the shaft based on the strength basis and then twisting moment. So that is a twisting angle. I will explain. So we will see how to solve the problems for a torsion problem. We will see. At the end of the course, the student should be able to demonstrate the principal stresses, principal planes already covered. In this, the torsional stresses acting on any arbitrary plane within the structure using analysis, analytical and more circle method already we have covered. So in this the last one topic is added here, the torsion of shaft and springs. So first we will discuss about the torsion of shaft and then we will see later springs problem. So problem solving on torsion. So whenever a given problem is a shaft, a solid shaft or a hollow shaft, so which formulas we have to use for calculation of torque? So already we have derived some equations and already we have learned some empirical relations in theory part. So those formulas apply for this given problem. A circular shaft, the type of shaft is a circular shaft of 50 mm diameter is required to transmit torque from one shaft to another. C is required to transmit. So what is the purpose of the shaft is? It gives power, transmit power from one place to another place. Suppose two bearings. So example, two bearings. These two bearings in between shaft is connected. So it means the bearing 1 and bearing 2. So this is a shaft, circular shaft. So the power transmit from one to another end. So one end to another end. So in this, find the safe torque. So due to the rotational motion, the shear torque will be developed. So which the shaft can transmit if the shear stress is not to exceed 40 megapascal. The shear stress is given. The shear stress not to exceed 40 megapascal. So the diameter of the length, the shaft is given 50 mm. So now the given, for any problem, first given data you should write. The given data, the diameter of the shaft, 50 mm. The maximum shear stress, 40 megapascal. Convert into Newton per mm square. Already I told you, 10 to the power of 6 Newton per meter square. So again convert into mm. So we will get say 14 Newton per mm square. So that you can say 1 megapascal is equal to 1 Newton per mm square. Clear? So now apply the torsion equation. So what is the torsion equation? 5 by 16 for a solid shaft, 5 by 16 into shear stress multiplied with the dq. So here, so actually shear stress is equal to 16T by pi dq. So already we have learned the torsion equation. T by J is equal to G theta by L. Okay. So apply this same equation for here and calculate. Here 5 by 16. And what is the shear stress? Sometimes they may not give shear stress. They will ask, they will give torque. Otherwise, if not available shear stress, have to assume based on the given shaft material. And diameter also given 50 mm. So now calculate 0.982 into 10 to the power of 6 Newton mm. So convert into mm. So sorry, meters. 0.982 kilonewton meter. See, it is a simple problem. Only one formula substitution. Next, second problem. A solid steel shaft to transmit a torque of 10 kilonewton meter. A torque given. In previous problem or not given, shear stress available. But here if the shearing stress is not to exceed 45 megapascal. Here also given shear stress. But what he has asked, find the minimum diameter of the shaft. In previous case, in previous problem, we don't know the diameter. So already given diameter. We don't know the torque. But in this problem, already available torque and then shear stress also given. Shear stress 45 megapascal. So diameter is asked. So for given data, torque 10 kilonewton meter converted into Newton mm. 10 into 10 to the power of 6. Similarly here also 45 Newton per mm square. So 1 megapascal is equal to 1 Newton per mm. So let D is the minimum diameter of the shaft. We don't know. We have to calculate. So what is the equation? The torsion equation. So already you know T is equal to 5 by 16 tau into dq. So in this torsion value you know and diameter you don't know and shear stress also given. So find here by using this equation D. Now the given torque 10 kilonewton meter is equal to 10 into 10 to the power of 6 Newton mm is equal to 5 by 16 into tau into dq. So 5 by 16, the tau value is, the shear stress value is 45 into dq, 45 megapascal. So substitute here, only unknown is d. We don't know. So this equation will get in terms of d value 8.836d. So now calculate d value. D is equal to 1.04 into 10 square. So you will get the diameter 104 mm. So like this, need to solve based on the given data. Next, in third problem, see somewhat different. A hollow shaft of here given type of shaft is a hollow type of shaft. is hollow. The previous case solid shaft. So external and internal, already you know the hollow shaft having external and internal diameters of 200 mm and 100 mm. Is required to transmit torque from one end to the other. What is the same torque? This torque is transmitted from one end to the another end. It can transmit if the allowable shear stress is 40 megapascal. The shear stress also given. So already you know for solid shaft, T is equal to pi by 16 into tau into dq. But this is not applicable here. So why? Because the given shaft is hollow. So use other empirical relation. I will show you this. The external diameter 200 mm. So internal diameter 100 mm. The allowable shear stress 40 megapascal. Torque transmitted by the shaft. Let's see, suppose here is solid shaft. Solid. For hollow shaft, so two diameters. One is internal and another one is external. So one is capital D, another one is this one is small d. The internal external diameter is only one diameter. Having a solid shaft only one diameter, but in this hollow shaft external diameter is 200 mm and internal diameter is 100 mm. Shear stress given. Now apply formula. So here the T is equal to pi by 16 into tau into d to the power of 4 minus small d to the power of 4 by d. So here pi by 16 into tau, external diameter available, internal diameter, and substitute those values in this. So sometimes they will give in terms of some ratio, that is K. The K is external diameter to internal diameter ratio. The ratio of external diameter, the external dia to internal dia. So pi by 16 into tau 40 into capital D to the power of 4 minus small d to the 4 by 200 Newton mm. So the torque is after simplification calculation you will get T is equal to 58.9 kilonewton meter. So next problem 3. A hollow shaft, here also given the type of shaft is hollow shaft, of external and internal diameters are same 100 and 40, the values are different here, is transmitting power at 120 rpm. Here power is given 120 rpm. In previous case is given torque. Find the power of the shaft can transmit if the shearing stress is not to exceed 50 megapascal. Here the power of the shaft. So if the shearing stress is not to exceed 50 megapascal means the shear stress, here not given power at speed. So this is N. Power at 120. Need to calculate. So apply given data, external diameter 100 mm and internal dia 40 mm, and the speed of the shaft is given 120 rpm. The shear stress given shear stress 50 megapascal converted into 50 Newton per mm square. So torque can be transmitted. So already you know, for a hollow shaft. For a hollow shaft. Solid shaft already you know. Already we have discussed. Once again recall. For solid shaft, T is equal to pi by 16 into tau into dq. So now substitute those values and we will get torque. Up to here already we have seen in previous problem. Now further, so we have to apply the power transmitted equation formula. So 9.56 kilonewton per meter available the torque. Now power transmit is equal to 2 pi nt by 60. So in this n rpm 120 rpm and torque is 9.56 already we have calculated. So substitute here we will get 120 kilowatts power. So if you know the power, sometimes they may give power value. So need to calculate torque. So in this, you have to write this equation, the above 16p by 2 pi n. So power value they will give and RPM also available. So calculate, you can calculate torque. So vice versa. Sometimes if you know the torque, you can calculate power. If you know the power, you can calculate torque. Okay, next problem. In this, have seen find the angle of twist for meter length. What is the angle? That is theta of a hollow shaft of 100 mm external and 60 mm internal diameter. If the shear stress is not to exceed 35 megapascal, take C here modulus of rigidity. This already know modulus of rigidity. C or G. So up to now we have calculated power, a diameter or torsion based on the strength. But in this, what is asked the twisting moment. So already we have seen the torsion equation. So apply this torsion equation. Find the angle of twist per meter length. Suppose here given a shaft is a hollow shaft. So whenever it starts to rotate, it transmits power one end to another end. At the same time, the twisting also available. So due to this twisting moment, the shear stress will be induced in this shaft. So how much twisted here? This is the angle theta. So what he has asked for the 100 mm length. So the length of shaft is 100 mm. External dia capital D and internal dia. Shear stress is not exceed 35 megapascal. So what is this angle? So first of all, given data, length of the shaft 1 meter, converted into mm, external dia 100 mm, internal dia 60 mm. So the maximum shear stress is 35 megapascal. So 1 megapascal is equal to 1 Newton per mm square. So 35. So the modulus of rigidity, that is C, 85 gigapascal, converted into mm square, Newton per mm square, you will get 85 into 10 cube. So 1 giga Pascal is equal to 10 to the power of 9 Newton per meter square. So in mm, 10 to the power of 9 by 10 to the power of 6 Newton per mm square. So we will get 85 into 10 cube Newton per mm square. So let theta angular twist in the shaft. Need to calculate. So first calculate torque. The given shaft is hollow shaft. So you know hollow shaft 5 by 16 into tau into external diameter d to the power of 4 minus internal diameter d to the power of 4 by external diameter. Substitute those values. You will get torque transmitted by the shaft. So how much got? 5.98 into 10 to the power of 6 Newton mm. So here in this problem, what he is asked to find the angle of twist for unit length. So the torque got calculated, the shear stress given, and external diameter d and a small internal diameter 60. Now calculate the polar moment of inertia for a hollow circular shaft. So that is J is equal to pi by 32 to the to the power of 4 minus d4. This is hollow shaft. Hollow shaft. For solid shaft, J is equal to pi by 32 to the to the power of 4. This is for solid shaft. So now calculate the given shaft is for hollow shaft, so that calculate polar moment of inertia for hollow circular shaft. So D you know, capital D, and the small d also you know. So that is capital D is 100 and the small d is 60. Substituting this, you will get J value 8.55 into 10 to the power of 6 mm to the power of 4. Now apply the torsion equation. Torsion equation already we have derived in theory part. T by J is equal to C theta by L. C theta by L or G theta by L is equal to tau by R. Shear stress. So now take in this torsion equation the first part, T by J is equal to C theta by L. So here C or G modulus of rigidity value given, and J polar moment of inertia already we have calculated 8.55 5 into 10 to the power of 6. Polar moment of inertia. For hollow shaft. For hollow shaft. So T value already we have calculated 5.98 into 10 to the power of 6 in Newton mm, and substitute those calculated value in this. C is 85 into 10 cube. Theta we don't need to calculate theta. So now the obtained value, the theta is equal to 5.98 into 10 to the power 6 by 8.55 into 10 to the power 6 into 85. So this value first calculate, then equate to 85 theta. So now we'll get the theta value, that is 0.008 radians. So finally, the theta, the angle of twist is, will get in degrees, this is angle of twist, theta. .5 degrees. So like this, need to calculate the angle of twist based on the twisting moment. In torsion, two things are there. One is strength basis energy, another one is twisting moment. So sometimes they may ask angular twist, sometimes they may ask torsional shear stress or torsion, and then power and torque. So remember these equations, so it will be useful for our problem solving. So next problem 5, calculate the maximum torque that a shaft of 125 mm diameter can transmit. If the maximum angular twist is given 1 degree in a length of 1.5 meter. So the length is 1.5 meter. The angle is 1 degree. Given here. In previous session we don't know the previous problem. So already available here. So now need to calculate angular twist. But what is the maximum torque? Diameter is 125. Remaining the C value gigapascal, that is modulus of rigidity. Now given data, diameter of the shaft 125 mm. The angle of twist 1 degree converted into radians, multiply with 1 into pi by 180, will get in radians. So the length of the shaft 1.5 meter, 1.5 into 10 cube. Modulus of rigidity 70 gigapascal, converted into Newton per mm square. So let T the maximum torque the shaft can transmit. We know that the polar moment of inertia of a solid circular shaft J 5 by 32 into d cube, sorry, d to the power of 4. So here shown the maximum torque of the shaft can transmit. We know that the polar moment of inertia of a solid circular shaft is J is equal to pi by 32 into d to the power of 4. Already you know for solid, this is a solid shaft. For hollow shaft, J is equal to pi by 32 d to the power of 4 minus d to the power of 4 by capital D. This is for hollow shaft. So now substitute the given diameter, the diameter 125. And finally, we'll get 24 to 10 to the power of 6 mm to the power of 4. So T by J, apply this torsion equation. T by J is equal to C theta by L. So what he has asked? The maximum torque. So you don't know the torque. So that you can write this equation, T is equal to C theta into J by L. Modulus WJD you know, theta also given, and J value already calculated for solid shaft, and length also available. Substitute those values in this equation, you will get the T by J value. Clear? So theta value also substitute 5 by 180. So T is, you will get 19.5 10 to the power of 6 Newton mm. So finally we will get 19.5 kilonewton meter. Here we have calculated torque. So only the difference is in the previous problem, the angular twist I have calculated, in this the maximum torque. So by using this torsion equation. So like this, we need to solve the problems on torsion. These equations are, these empirical relations are very important for this problem solving. So these are the references I have taken. Yes, Ramamrutam. Title of the book is Strength of Material, and R.K. Bansal, Textbook of Strength of Material, and then publications are Lakshmi Publications, and R.S. Kurmi and Gupta, Strength of Material, title of the book, and then publishers are Rachan. So take any one reference for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.